Welcome back to the DataWeave Learning Series. In today's session, we're going to explore an important concept in MuleSoft integrations, how to efficiently handle large payloads using pagination, chunk processing, and streaming patterns. In real-world enterprise integrations, we often work with large datasets such as product catalogs, customer records, transaction data, log streams, or batch API responses. Sometimes these payloads can contain thousands or even millions of records. Processing the entire dataset at once can lead to several challenges. For example, Mule may load the entire payload into memory during transformation, which can result in high memory consumption. Large payloads also require more processing time, which can lead to slow transformations and poor API performance. In some cases, especially in environments like CloudHub where workers have limited memory, this may even result in out-of-memory errors. Under heavy loads, integrations may also become unstable, causing flows to slow down, time out, or fail. That's why techniques like pagination, chunk processing, and streaming are essential patterns in MuleSoft architecture. Let's start with a simple pagination example in DataWeave. In this script, we first define the DataWeave header and set the output format to JSON. Next, we define a variable called page, which represents the current page number requested by the client. Then we define page size, which determines how many records should be returned per page. Using these values, we calculate the starting index using the formula page minus 1 multiplied by page size. This calculation helps us determine where the requested page begins in the array. Finally, we select the records using a range selector on the orders array. This retrieves only the portion of the dataset that belongs to the requested page. For example, if the page size is 5, only 5 records will be returned in the response. If the page size is 4, then 4 records will be returned. This pattern is widely used in APIs because it ensures that clients receive smaller and more manageable responses instead of very large payloads. Next, let's look at another useful technique, splitting arrays into chunks using the divideBy function. In this example, we import the arrays module from DataWeave, which provides useful functions for working with collections. We then use the divideBy function to split an array into smaller groups. For example, dividing the array 1 star to 2, 3, 4, 5, 6 by 3 results in 2 groups, 1 to 2 to 3 and 4 to 5 to 6. This technique is useful when we want to process data in batches instead of processing everything at once. Next, I demonstrate multiple examples of the divideBy operator showing how arrays can be split into groups of different sizes. For example, dividing array by 2 creates smaller pairs of elements, while dividing the same array by 3 produces larger groups. These examples highlight how flexible the divideBy function can be when working with large datasets. Another powerful capability in MuleSoft is streaming. Streaming allows Mule to process data as it is being read, instead of loading the entire payload into memory first. This becomes extremely important when working with very large files, such as large CSV datasets, log files, or massive JSON and XML payloads. When streaming is enabled, DataWeave processes the data record by record rather than loading the entire file at once. This significantly reduces memory consumption and improves the overall performance of the integration. Streaming is commonly used in scenarios like processing large CSV imports, handling event streams, or integrating with systems that generate high volumes of data. Streaming is usually demonstrated with very large files, but for explanation purposes here I'm showing a smaller JSON dataset. In the next section of the script, we transform the incoming payload using the map function. Here, we iterate through each item in the payload and create a new structured object containing fields such as product ID, product name, and price. This type of transformation is extremely common in MuleSoft integrations, where we often need to reshape or standardize data before sending it to downstream systems. In real MuleSoft implementations, chunking techniques like this are frequently used with batch jobs, bulk API operations, and high-volume data processing pipelines. When combined with pagination and streaming, These patterns allow us to build integrations that are scalable, efficient, and capable of handling enterprise-scale data volumes. And that's the key takeaway from today's session. When working with large data in MuleSoft, we should always think about how the data is returned, how it is processed, and how it is handled in memory. By using techniques like pagination, chunk processing, and streaming, we can design integrations that are high-performing, scalable, and production-ready. If you enjoyed it, please like this video and subscribe to my channel MuleSoft Unleashed for more updates. And don't forget, drop a comment if there's something specific you'd like me to cover in the next video.